An engineering student at ENSAM Casablanca, I spend a lot of time looking at complex physics diagrams. But there's a problem. Static 2D sketches don't always translate well to 3D reality. In engineering, missing the spatial context of a vector or a force can be the difference between a solved problem and a failed design. I wanted to bridge this abstraction gap. I wanted to create a tool that doesn't just solve the math, but builds the spatial intuition. That's why I built PhysiViz, a lens that brings the physics into 3D focus. Let's see it in action. For problem inputs, we can either upload an image or type the problem. I'll type in a classic mechanics problem. A 5-meter cantilever beam is fixed at the origin with a downward force of 500 newtons applied at its tip. In the matter of seconds, the Gemini API parses those natural language constraints and transpiles them into 3D objects. Thanks to 3.js, we can now rotate, zoom, and inspect the spatial visualization. We get the cantilever beam, the supports, and the force. Notice that we also get all objects into a neat list on the right, as well as some additional data. We can also ask the AI tutor questions relating to our problem. For example, I will ask him to calculate the shear applied. We immediately get a nice markdown result. Finally, when you're done and ready for your next problem, you can easily input a new problem by clicking the New Problem button. You can check out the codebase at the GitHub repository link on screen. The structure is modular and type-safe. Our Gemini service.ts acts as the brain, handling structured data extraction from the Gemini API. The scene viewer.tsx is our eyes, rendering those parameters using a React 3-fiber loop. The chat interface and infopanel.tsx are responsible for the info panel on the right and the tutor interface. By using TypeScript, I've ensured that the contract between the AI's output and the 3D renderer is rock solid. This modularity means we can eventually expand from static visualizations to full dynamic simulations.